So I fixed the system. So everything that I messed with was the display for the adder, the comparator, and the display for the comparator as well. So to begin with, the original circuit that Nader had sent in, that Nader gave me, was correct. It displayed everything that it needed to. It was actually already in the two's complement system. The problem was is that I got confused with the two's complement system and a signed magnitude system. So if you look on the right here, I'm sorry, I should have actually did the signed magnitude over here. So as you can see here, this was one of the things that was pretty prevalent in our system. So 1000 or 1000 is actually -8 in the two's complement system. Whenever we were displaying 1000, we were actually displaying -0, which is incorrect. It's wrong. So I fixed that. So that's the truth table for, I guess that's a truth table? Yeah, that's a truth table or the equivalent values for signed integers or signed binary numbers. So to start off, we'll look at the display for the adder and subtractor. So right here we have the sum, the overflow, the most significant bit, and the OP code. So basically, there are two enablers within this system. There's the OP enabler, and then there's the overflow enabler. The overflow enabler is supposed to work like the master enabler. So that basically means that it basically dictates the whole entire system. And this is also the most significant bit, which tells whether or not it's a negative or a positive number. Here's the comparator right here. So this, I'm only going to show you one circuit because they're practically the same thing. They just did different couple values. So we have our x and our y here. This is also running on 2's complement, which the previous one was running on signed magnitude. And this connects into either I or U based on certain things. So we know that x being less than or equal to y is equivalent to an I output. The same and vice versa for x is greater than or less than y. If that's true, then it displays U. I'm going to show you what the display looks like. Simply put right here. There's not too much to explain. So now I guess let's run through some values, my friends. So just to show you that this number here, right here, works, we're going to display 100 in both x and y. So we have -8 here, -8 here. So let's do a couple additions. So let's do a negative number. So they all basically work. So 7, 5, 1, they all work. And the same thing for down here. So let's add some numbers together. So let's do a negative first with a positive number. So -8 plus 1 is -7. -8 plus 2 is +6. -8 plus 4 is is -4. Now let's do a negative number. Let's test the overflow. So -8 plus -8 is an overflow. Basically shuts down the whole entire circuit. Um, so let's do another negative number. So let's do something that's smaller. So let's do -8, or let's do -7 plus -1. We get -8. Also refer this table right here if you have any question or if you have any problems. Just pause the video whenever you want. Let's do -7. Anything is an overflow. So that works. So now let's do a little bit of subtraction. So we'll do a subtraction here. We'll do -8 minus -8. We'll get 0. We'll do -8 minus -4. We'll get -4. So let's do positive number minus a negative number. A 1 minus -3. So yes, all these values do work. Now I'm going to move on to the comparator display. So as you can see here, x is less than or equal to y. That's the case. So let's do x is that right there. So it turns off. X is not less than y because y is 0 and x is 1. So let's do 1 and -8. That's true. negative 1 is not less than negative 8. So let's switch that code over. In this case, x is greater than y. 1 is greater than negative 8, so it displays the values here. This, I don't know why the hell that's turning on, but whatever. All these values are correct. So everything works properly. That's practically it. If you have any extra questions or any other concerns or anything, just be sure to put it in the group chat, and we'll go from there.